the emergency control. Okay, so last class we have learned about the emergency control, how to carry out the emergency control, and then when we have to carry out the emergency control, we have learned that, right? But first case, what we have learned is first case in the sense, yesterday's lecture is when that equipment limits are violated. Example, thermal limit we have considered. If it exceeds 1500 megawatt, okay, then what it happen is a blackout may happen, right? So in such case, how to carry out the emergency control we have learned. Okay, so today we will see if synchronism loss, or if there is loss of synchronism between the generator, how to carry out the emergency control. Okay, so normally there will be two types where you have to carry out the emergency control. First one is if it is violating the equipment limits. So example, I have given one example is thermal limit, and then we have also seen that other emergency control that all fall under the equipment limit violation. So now today we will be seeing about the uh, if there is losses of synchronism between generators. So when there is losses of synchronism between the generator, then we call it as angular instability. Okay, so if there is a losses of synchronism between the generator, then it is called angular instability. So if there is a angular instability, then how to carry out the emergency control. Okay, so today we'll learn about the angular instability and emergency control. Okay, so first case, let's consider. Okay, so now we have to create our own scenario because it has not happened, right? It is not a real one, but we have to create our own scenario. So that's why I said let us now consider a situation or scenario wherein an emergency is caused by loss of synchronism between generator. Okay, so let's just see here other explanation, everything I will explain here. So now here in this, let's see. Okay, so there are four generators. Okay, so G1, G2, G3, G4. Okay, four generator, and then each generator or each unit is generating 1000 megawatt. Okay, so equally we have considered that equally it is generating four generator generating 1000 megawatt each, and then we have, okay, just consider, or we have created this scenario that at this bus there is load. Okay, this load it requires 1000 megawatt, and then similarly at this bus there is load connected here, and then this we have demand of or load is requirement is 3000 megawatt. Okay, so actually this is called it as a four generator system, each generating equal, we have considered equal, okay, 1000 megawatt. And then at this bus, so here I have not given bus name, but you can keep bus 1 and bus 2. In bus 1 load requires 1000 megawatt, and in bus 2 load is connected and requires 3000 megawatt. Okay, so now see here, if you look it carefully at the bus 1, you require only 1000 megawatt, but generation is, so total it has been connected here, generator 1 and generator 2, so 2000 megawatt, so which means 1000 megawatt is excess. And if you look at bus 2, your total requirement is 3000 megawatt, and then generation is only 2000 megawatt, because G3 and G4, generator 3 and 4 is generating 1000 megawatt each, so which means total it will be 3000, sorry 2000, and then your demand is 3000 megawatts. So in such case what you can do is you can buy from the bus 1, so not bus 1, from this generator 1 and 2, right? Because here it is a excess generation, here it is a deficit generation. So now here in this case I have created two transmission line or line, each carrying 500 megawatt each. Okay, which means this 1000 can supply to this load, another 1000 you can supply to the bus 2. So that's how we will get 3000 megawatt. But here we have assumed the ideal case. Okay, there is no losses at all. But in actual case, there will be losses and all. But here, just to create a scenario, I have created there is no load, which means this bus 1 and 2 are voltage independent, and their loss is very negligible, which means no loss at all we have considered. Okay, so you see here 1000 megawatt, then here from here we'll transmit the 500 megawatt each, and then that's how we will fulfill the demand. So if you see carefully here, so after fulfilling all the required demand and then generation, you can see that no equipment limit is violated here. Okay, so this line can carry 1500 megawatt, but it is carrying only 500 megawatt. Similarly here, 1500 megawatt, but it is carrying only 500. So no equipment is limit is violated, which means it will be stable. Okay, okay, so this is a normal. Then now in power system, you will know that there will be a lot of relays installed here. Okay, so let's assume that relay has been installed at this end, and then let's consider one cases where fault has been occurred in one of the line. Okay, so that diagram 2. So there's fault occurred, and then this fault will be sensed by relay installed at this end, right? Bus, and then what it will do is this relay will give a tripping signal to the circuit breaker, and then it will trip off, right? Or this line will isolate, or it will try to clear the fault. Okay, so case we have considered here is there is one fault occurring at the line which is carrying 500 megawatt, not both the line. We have considered here only for a one line which is carrying 500 megawatt, and then this fault is sensed by relays which is installed at the end of your bus, and then this will give a tripping signal to the circuit breaker, and this line will be trip off, right? So when it trip off, what it happen is, so now here we require is 1000, here we require total demand will not trip off. Okay, so total demand required will remain same, generation will remain same, only thing is line is okay. But in such case, we can transmit via this line, because we can add up here 1000 megawatt. Okay, so initially it is carrying 500 megawatt, but even when there is fault in the one line, then we can transmit. So here, if we see carefully, we can observe that even it is not violated any, okay, it is not violated any equipment limit, right? So because each line will be carrying 1500 megawatt, but here it's carrying 1000, and this is how demand will be fulfilled. Okay, so this is scenario one we have created, and then here this fault has to be clear, right? So how fault will be clear is fault clear by opening a circuit breaker at the two ends of the line which is installed here, and then you will clear that, and then from this line, so you will transmit how much, 1000 megawatt. So which means it will be within the limit. Okay, this here we have considered within the limit only, which means no need of carrying out the any emergency control here. Okay, because this line can withstand, okay, 1000 megawatt, or it is within the limit, and then you can isolate this line and transmit the power through this line, and then you do this maintenance, and then you can again bring back to the normal situation like here. Okay, this is how we can do. Okay, in this case no need of any emergency control. Okay, so this is a real picture which I have taken out from the internet. So this is how normally angular instability will occur. Okay, so this normally fire may catch up in this, and okay, you try to see that, but scenario we have to understand is, first we have seen that, second case their fall is occur, and then we try to isolate that and line, and then we transmit via other line, and then still it is within the limits. If it is within the limit, then no need to carry out the emergency control, right? But why we have to do emergency control here is, if we keep on like this for a longer duration, so what it will happen if there is fall occur in this line, this has not been restored, you have not done any maintenance or a restoration or emergency control or control in this line, and you have kept as it is because with this is within the limit, right? But if fault occur here, what it will happen, so complete blackout may happen, right? Or so this side there will be excess generation, load required is 1000, but you will have 2000 megawatt generation, and this side what it will have is you will have deficit of generation. Load demand is more than the generation. So in order to avoid that, so we have to carry out the emergency control. This because it is in the emergency stated as soon as. Okay, so then okay, so now what we can see is, so now here we can say that it is within the limit. Okay, it is within the limit. Everything is within the limit. That means equipment limit. But we have to ask to ourselves that question: when the steady state scenario following the loss of line does not cause violation of equipment limits. See here, it has not violated any equipment limit, but we have to ask question to ourselves. Okay, question arises: will this system reach a steady state or not? If it comes back to the steady state, we know that it will not violate any equipment limit. But whether this system after disturbances here, because one generator may have to be speed up or one has to be slow down, and then there will be angular differences. So will this bring the system back to the steady state or not? If it brings back, then it is good, right? We are not required to do any emergency control because it is not violating any limit, equipment limit. But if it is not bringing to the steady state, means it keeps on in the transient state, then what we have to do? Okay, if it bring back to the steady state, then it is well and good. But if it is not bringing back to the steady state, what it happen is, so then in this transient state, so we will not be able to supply the required demand. Okay, or complete blackout will happen. So that's why we have to do an emergency control. So in this case, we will not talk about the equipment limit violation because it will be within the equipment limit violation, but we will see angular instability. Okay, which we that equipment limit violation already we have learned in earlier lecture. Okay, so now first case we will consider that okay, it will bring back to the steady state. Okay, so first case it we'll consider that it will bring back to the steady state. When it will bring it to steady state back, okay, so we'll see with this scenario. Okay, so now we'll consider that power has been actually this line is carrying 500 megawatt, but now because of fault in one line, fault occur in one line, it is carrying 1000 megawatt. It is not violating any equipment limit. Okay, so this power is within the limit only, and then phase angular difference between bus voltage. Okay, so that phase angular difference between these bus voltages, we'll see whether it will violate or not. Okay, so now first case we'll assume that it is not violating. So here power, okay, so power transfer is within the limit, and then we also see that this phase angular difference or bus voltage angular difference is within the limit, means it is not violating any. Then what it will see is, you can see that there is this has been occurred because there has been a fault occur there, right? But after some time it tries to bring back to the steady state, means transient in power in stable conditions. So normally there will be a disturbances because there is a fault, but after some time it will come back to the steady state. Okay, so similarly you will see that generator speed transient. Okay, four generator are there, so all speed there will be a disturbances in this transient state, but later on it will come back to the steady state. So which means okay, and then similarly this phi 1 minus phi 2 in stable condition. So initially when there is a fault, then there is a disturbances. After fault is clear, then it come back to the steady state. Okay, in such case, so no need to carry out any emergency control because as soon as fault is clear, it is coming back to the steady state. Okay, so this is the case we have considered one. Then another case we will consider is, so what it will happen if it is not coming back to the steady state like this. Okay, so after the fall is clear and then it's not coming back to the steady state. When it will not come back to the steady state, we have seen, I will explain here. Okay, so we saw that waveform when a system is angular stable after a large disturbance like a fault, right? When it is stable, then what it will happen is if the relative speed and angular deviation are excessive. Okay, so if the relative speed between the generator and then angular deviation are excessive, then the restorative torque will become negative. Okay, what it will do is this, it will become a restorative torque will become a negative. When restorative torque become negative, then it will not be able to pull back into synchronism, which means we call it as angular instability. Okay, so if the relative speed between the generator and speed and then angular deviation are very huge or excessive, then the or restorative torque may become negative. Okay, in this case, what it will happen is generator will not able to pull back into synchronism. So that is called it as angular instability. But if the relative speed and angular deviation are not that excessive, or difference is very less, then restorative torque will be positive, and then this generator will be pulled back into synchronism. That's how I've explained about this earlier slide. But now, under this case, we have assumed that relative speed and angular deviation are very huge or excessive. Then the restorative torque will become negative, and then under such condition, generator will not be able to pull back into synchronism. Means it is angularly unstable. Okay, so then we know that generator are connected to one another, right? For generator case we have considered. Then speed will not settle down to a common value, which means we see here. Okay, in this case, so you can see that power, it will not show any sign to coming back to the stability or steady state. Similarly, generator connected together, and then this you will not see that this four generator will be working at one common speed. Okay, so two generator may deviate here, another generator may deviate here. So here, just example, I have given generator one and generator two, and then generator three and four speed. See here, where it will not come back to the steady state. So we never know when it will come back to the steady state. And similarly, this phase angle will not be coming back to the stable steady state. So it may go to infinity. Right? So in such case, what it will happen? Blackout will happen. So later on, your complete system may have to shut down or damage will occur, and then uh, blackout will happen. Then you will not get a power. So now, in such case, we have to carry out the emergency control. Okay, so this one just a explanation it has been given here. Okay, so now how to carry out the emergency control. Okay, so in such case, there are two ways which we can control the carry out the emergency control. So first one is, so we have to make an island one and two. Okay, but how we will make it island? So for the example which we are considering, the tripping of line shown, split this system into two islands. So in such case, what we have to do is manually, if you required to do, okay, if it's not coming back to synchronism. So now what you can do is no other option. Okay, first option is you have to make it into island one and island two. Okay, so see here, I have made it into island one and island two, which means I will cut off this line also. Okay, system separate by opening of circuit breaker. We will try to separate these two system by opening of circuit breaker, and then we will make island one and island two. But problem we will face is in island one excess generation, because here we require only 1000 megawatt, but we are generating 2000. Here it will become a less generation, deficit in generation, more load. But no option, we have to carry it out. So that we will carry out the maintenance, and then we try to install back this line. Okay, so now first thing is what we can do is to avoid complete blackout, we have to make it island one and two. We have to separate, just open this line by opening a circuit breaker, and then we'll make island one. Here generally it will be more generation and less load, and similarly island two, we'll have less generation but more load, but no option. So some load we may have to shut off, and then here some generation we may have to shut down. Okay, so one generator you may have to shut down, and then we make only 1000. Okay, but why we are doing this is it is like a emergency, it is a emergency control, so that it will not enter to the blackout. So during that time we will try to reinstall this line, and then we will bring back to the. Okay, so this is how we will carry out the emergency control if angularly unstable. So if there is angular unstable, it does not mean that it will violate the equipment limit. So it will be within the equipment limit, but there will be in okay instability in angular or angular instability, which we have to take care of this. So then what it will happen is one generation island will have a more generation, less load, other will have a, but in such case what it will happen here, so if there is less load more generation, so now frequency will be problem, right? So in order to prevent a large and sudden drop of frequency, some load is shaded, means some load will be shaded off by sensing the frequency, or under frequency load shading we have to carry it out. That's why I said one generator may have to be shut down, and then we will make this. Here in this case, load has to be removed, certain load has to be removed, and then certain load has to be removed, which means 1000 megawatt load has to be removed, and then we will be able to supply only 2000 megawatt of load. This is how we have to carry it out. Then slowly we will try to install this, and then it will restore back. That control is known as emergency control. Okay, but to say theoretically it is very easy. Okay, to say theoretically it's very easy, but stabilizing the voltage and frequency in the island is not easy. Okay, so actually it's not easy due to the reduced cumulative generation inertia and possible low real and reactive power reserve margin. So but theoretically we can say, but practically it will be very difficult, but we we have to do that. Okay, so in a over generated island, so if we take it this a over generated island, generation has to be reduced quickly to stabilize the frequency. So see here example, in this island one there is over generation, right? But this generator has to be reduced quickly to stabilize the frequency, because load required is less, generation is more. When low load, speed will increase, which means your frequency will increase, so some part it has to be shut down quickly, right? which but this part will be performed by, you know, that it will be performed by governor and then all, right, AGC, which we have installed. Okay, but this is a concept which we have to know that. Okay, okay, so the first one is we are separating into island mode, and then we are doing the emergency control. So this control is known as a emergency control. Okay, so this is how we have to do that. And then another one is, okay, so now this is a concluding remark, but you try to read this, whatever I have explained in this lecture or in yesterday's lecture, it is repeating here. Then another way which we have can do is, this is the most preferable one. Okay, so nowadays we are trying to use this type of device. Okay, capacitor is inserted as soon as if you found out that it is angularly unstable, or phi 1 minus phi 2 is found to be very large, then you will try to install the capacitors. Okay, and why we have installed, so already we have learned, and then we will try to bring back to the stable, okay, condition. So this condition is also known as controlling of this by this method is also known as a emergency control. Okay, so this is how we can do it. Okay, so this possible emergency control is illustrated in figure below, which means in this figure, and sudden change in triangular separation between two ends of a line can be made to trigger opening of a circuit breaker in the figure. And then what you will do is you will try to insert a capacitor as soon as it is found to be. Okay, why we are installing the capacitor is to boost the transient electrical power flow through the line to reduce the effective reactance. So it will try to reduce the effective reactance, and then it will boost the power flow, electrical power flow in the transient state, and which it will de-accelerate the generator G1 and G2 and G3 and G4. Okay, so this is how, or which we in turn will de-accelerate the relative speed between the generator group G1, G2 and G3. So if it is de-accelerating, then your angular differences will come back, or it will be small. It will not go beyond, or it will not be a large one, so it will be a small. So if it is small, then we know that it will bring back to the steady state. Okay, this is how we have to carry out the emergency control if it is angularly unstable. So earlier one, it is very difficult to carry out, but this one most of, and the preferable method is we use this inserting a capacitor. So now what, inserting a capacitor, how you will try to minimize the phi 1 minus phi 2. So what it will do is it will boost, when you insert a capacitor, it will boost or increase the electrical power flow, transient electrical power flow. Why? Because it will reduce the effective reactance, and then when it increase the electrical transient electrical power flow, what it will happen is it will de-accelerate the relative speed between the generator group G1, G2 and G3, G4. If it reduces the, or if it de-accelerate the relative speed, then it will reduce the phi 1 minus phi 2, and if it reduce the phi 1 minus phi 2, then restoring torque will be positive, and then if restoring torque is positive, then it will bring back to the steady state. But if you have not installed this, okay, and then you are not doing manual one, which I have explained earlier, so this phi 1 phi 2 will be become larger and larger. This difference, okay, which we call it as angular difference, will become larger and larger. When it become larger, what it will happen is then your restoring torque will be negative. If your restoring torque is negative, what it will happen is this torque will not able to bring this generator group rate, okay, or let's say this, it will accelerate the relative speed between generator 1, 2, generator 3 and generator 4, and then when it accelerates, so what it will happen is your restoring torque is becoming a negative, and it will not be able to bring back to this synchronism. Synchronism is all this generator has to function at one common speed, so which means it will not bring back to the common speed, and then so it will not bring to the steady state. So even though that it is not violating any transmission line limit, okay, or equipment limits, so it will lose the synchronism. So in such case, we have to carry out the emergency control. Okay, so that's all about today's lecture. Okay, so today we have learned about the emergency, how to carry out the emergency control if there is angular instability, and then there are two ways which we can do that. And when angular instability occur, I have explained here. Okay, so with this, okay, so I have completed the emergency control. Okay, so there are two ways which emergency control we have to carry out. Okay, first case is when it violate the equipment limits. Another one is when it lose the synchronism or angular stability. So for respective one, there is a different ways which we can carry out the emergency control. So now in this lecture, you have to know that why we have to carry out the emergency control. We are required to do an emergency control to avoid entering to the blackout, right, or in extreme state, or to bring back to the alert state or normal state of the power system. Okay, so that's all for today's lecture. And then if you have anything to share, let me know. Okay, so it seems there is no doubt, and then that's why we are completing our syllabus a little bit faster, right? So no doubt. If you were here, then somebody will ask out, or I will sense through your face, and then we repeat again and again. So then we lag behind our work plan. But actually, by work plan we have to complete by May end. So and then it is as per the work plan we are completing. Okay, but how much you have got it is a question mark. Okay, and then we never know when college will be open or school will be open. So when it open, I think definitely they will not conduct exam immediately when you join here. So around at the minimum, I feel 2 weeks to 3 weeks they will provide. So that time, if you have doubt, or they may allow the timetable for clearing the doubt also. We may go in the class and then clear all the possible doubt. But I may not be able to take like earlier, right, from the first unit to the end of last unit because time will be limited. So when you join back, we'll discuss which topic you have found very tough, and in that area we will discuss. Okay, that's all for today's lecture, and then we are coming to the end of our syllabus. So most probably tomorrow we will be completing, and then after completing that, so what I have planned is, so whenever you are free, okay, so which means there is no test and then no assignment submission, that time I will perform one class test and we'll keep all assessment mark. Okay, your CA mark ready. Okay, CA mark, when you come back here, I will not assess. Everything will I will complete now, and then it will be kept ready. And then as soon as you join here, we'll clear the doubt, and then semester end exam will be conducted as per the timetable. It will be issued by the dean, office of the dean academic. Okay, so all assessment part we will try to complete. I will not give assignment more now. I have given 2 assignment. Actually I have planned to give 4, but because of this situation I have reduced to 2. Already we have completed. Class test 1 has been done, phase test has been done, so only left is one more class test, and then with that we are completing all the assessment. Okay, so thank you for coming online, and then I hope some of you are
Sir,
attending
what
the.
about our practical, sir?